Hi guys, welcome back. We're going to start talking about solving equations, and this is very important. I want you to write all of your work on a sheet of paper, and I want you to show your work, okay? Now I know some of you, Miss Hawes, I can do this in my head, and that's great, okay? But we're practicing showing our work so that way as we get into harder stuff, we can do it better, okay? So when we're solving equations, our equal sign is our balance beam. So I want you to draw a line through the equal sign, okay? If you want to draw a dotted line, that's fine, okay? So what we do to one side of the line, we have to do the other, okay? We can't just willy-nilly be like, oh, it's fine, you know, whatever. And what I want you to think of is, remember when we did PEMDAS way back when, right? When we're solving an equation, okay, it's basically like trying to take your shoes off at the end of the day, right? You should untie your shoe, take your shoe off, and then take your sock off. You wouldn't take your sock off before you took your shoe off, right? That wouldn't make sense. So when we had expressions, we went this way with PEMDAS, right? Well, equations are just trying to undo what we did in an expression, okay? Or what we did with PEMDAS. So we go backwards when we're solving an equation, okay? So we get rid of our addition, subtraction first, then our multiplication, division, so on and so forth, okay? So here, I'm adding 7 to x, right? So I want to get rid of it. So what's the opposite of adding? Subtracting. So I would subtract 7 from both sides of my balance beam here, right? Okay. So then x, nothing happened to it, so we're bringing the x down. Well, a positive 7 and a negative 7 cancel to be 0. Since I already have an x there, I don't have to write 0, because if I wrote plus 0, x plus 0 is just x. Is equal to 9 minus 7, which is 2. So x equals 2. Which makes sense because 2 plus 7 is 9. And again, some of you are like, Miss Hawes, I know x is 2, and that's great. You're going to go through the process and show your work anyways today, okay? All right. Now this one is kind of throwing you for a loop here, right? We have a negative 3 plus x equals 6, okay? So I want to get rid of the negative 3, and it's being added to x. But remember, whenever we have a negative sign, that's like subtracting, okay? So to get rid of a negative 3 to make it 0, I need to give a positive 3. And what I do to one side of the equals, I'm going to do the other side of the equals, okay? So negative 3 plus x, okay? We're going to add 3. So negative 3 plus 3 cancels. Bring down the x. This equals 9, which makes sense because negative 3 plus 9 would give me a positive 6. So I can always check my work by plugging the x value back in. So wherever we see an x, we put a 9, and negative 3 plus 9 equals 6. Okay? All right, let's try this again. Now this one, it's 3x. Now remember, whenever a number is sitting right in front of that variable, there's an invisible multiplication sign. So what's the opposite of multiplying? It's dividing, right? So we're going to go ahead and divide 3 on both sides. Now notice I did not use this wonderful division sign, okay? We're going to use a fraction bar because sometimes our answer is going to be a fraction, so it's a lot easier to deal with if we use the fraction bar to start with. So 3 over 3 cancels to be 1, so I'm left with 1x, or just x, right? You don't have to write the 1. And that's what I want. I want x to be by itself. Is equal to, well, we have negative 15 over 3, and negative 15 over 3 reduces to negative 5 over 1, which would just be negative 5. And again, I can check myself. 3 times negative 5 gives me negative 15. Okay, why don't you go ahead and try this one for me? So again, I'm going to draw my line with my wonderful balance beam, right? So again, this is where a lot of students mess up. They tell me, they're like, oh, I need to add 5. But the 5 isn't being subtracted from x even though it's negative, right? It's really being multiplied because there's no operation between those two numbers. So I'm going to go ahead and divide both sides by negative 5. Again, I'm using my fraction bar instead of my division sign. The negative 5 over negative 5 becomes a 1. So I'm left with x equals negative 20, and over negative 5 reduces to a positive 4. Okay, because remember, a negative cancel to be positive. All right, let's look at this one. Again, we're going to draw our line here. This is really x over 4, and I'm going to write it like a fraction. So a question I always ask myself, and what you can be asking yourself, is what is stopping x from being by itself? And that's 4. And then you say, what is x do, or what is 4 doing to x? Is it adding, subtracting, multiplying, or dividing? In this case, it's dividing it, right? So I'm going to multiply both sides by 4. because 4 over 4 cancels to be a 1, right? Okay, so I'm left with 1x, or just x, and then 5 times 4 is 20, which makes sense because 20 divided by 4 equals 5. Okay, so go ahead, why don't you try this one? So we're going to have y over 5, negative 5, I'm sorry, equals 6. So again, negative 5 is stopping y from being by itself. It's dividing it, so we're going to go ahead and multiply both sides by negative 5. So we're going to get y equals negative 30. Okay, because positive times negative is negative, 5 times 6 is 30. And I believe that's it for today. So again, I know some of you are going to be super resistant to showing your work, but please, please, please show your work so when we get to the harder problems, you're used to showing your work, okay? Have a great day, and we'll see you tomorrow. Bye.